recently I was testing a feature in mixed reality, and I came across one of those moments that just makes you go, wow. What was happening is I was playing a game in mixed reality where we had taken a physical wall and replaced it with a virtual wall. Now, to kind of give you the idea of what it was like, think about this wall that's over to your right here, and imagine it as if you replaced it with outer space. And so as you look out there, there's planets, there's comets whizzing by, maybe a few asteroids, maybe even a few aliens. So anyway, I was playing this game, and another product manager came up, tapped me on the shoulder, and asked me a question. I took off my headset and turned and saw that that wall was no longer there. It actually startled me. I took a step back and was like, wow, what's going on? Now, to be clear with this, it wasn't a safety issue. I was more than 6 feet away from the wall, and the app I was playing had a warning thing saying, hey, you're getting too close if you got too close. So it wasn't anything about my personal safety. It was that my mind had suspended disbelief. It had really incorporated that vision of reality into my mental model. So when suddenly it wasn't there, I was surprised that it wasn't there. Well, this is exactly the type of experiences that we would like to enable you to create in mixed reality. It's that type of experience where your mind just blurs the difference between the physical reality that you have and the mixed reality of the virtual objects. You suspend disbelief and you really think you're there, and those virtual objects are really interacting like they should. The good news is, with the tools and technologies that we have now and that we'll describe many of in this presentation, we actually give you that ability. You can merge the physical world and the virtual world and have them blend reasonably. Now, we broadly characterize this, these tools we'll be giving you into two different areas. The first one, to allow the immersive experiences, is an area we call perception. Now, what perception allows you to do, it gives you those cues that really anchor you well in the virtual reality. It starts with pass-through so that you get a clear image of the pass-through, but it extends beyond that. It extends to the depth API so that you can place the object in the right place. It even extends to the shadow and lighting. The shadows light up like they should, the object looks real. The shadows that extend from them actually ground them on the floor. All of these things are super important in really creating that illusion that we want, and like I had that I described earlier, where your mind thinks these things are real. So we call that perception, and we'll be talking about that in the first part of this presentation. The second part of the presentation is going to deal with adaptive interactivity or interactivity. Now, what we mean by that is once you get those objects working in that mixed physical and virtual world, you want them to react naturally. You want occlusions to work as they go behind stuff. You want shadows to be casted so that they're grounded to the floor. All these things are, just really add to the experience and give you the tools and capabilities to create that. As I said, the first part of this talk will focus on the perception, second part on the interactivity. Now, let's talk about what it takes to really create a mixed reality game. Unlike traditional games where the developer totally controlled the scene, in a mixed reality game, you're actually placed into a physical room somewhere, and both the gameplay and what you do in it, the objects, have to adapt to that room. Maybe one room has a bed in it and another room has a table. Another room has neither a bed or a table. How are you able to create the gameplay that adapts to these different environments, is still fun for your user, and still gives a dynamic experience? That's the challenge that we have. As we said, it all starts out with pass-through, and so we'll spend a lot of time on it as we start this talk. But after you get through pass-through and things, you can see them clearly with no distortion, no issues, you then move into you want to augment it. And augment, we mean add those virtual objects or the decorations and everything that you want to really create a really cool space. Finally, what you would like to do is, in many cases, capture that environment and share it with your friends and family. Now, the interactivity stuff that we talked about should allow you to create gameplay that can adapt to any room environment and really solve a lot of those problems for you. Now, what we found is that a lot of the MR developers were recreating all the stuff they needed to do this from scratch. So we decided to build a set of tools and package the most common issues or most common building blocks that we could into a development kit that we call the Mixed Reality Utility Kit. And so we'll be talking about that a lot during the second half of the talk, where we're talking about the interactivity. So to get us started with the first part, which is the perception, I'd like to introduce you to my colleague Avinav, who will take us through the improvements that we've had in the Passthrough API over the past year.
All right. So there are two crucial components of mixed reality, as we have seen, pass-through and occlusions. And this year at Meta, we have been really focused on raising the bar for both of them. And I'm genuinely excited to share the progress that we have done so far. But before that, let's start with the basics. So pass-through captures your camera's view and converts it into a live 3D reconstruction on your device. Occlusion, on the other side, provides the intelligence for the virtual objects to be obscured by the real-world objects, mimicking the natural way objects interact with each other in our surrounding. Now, we know that building for mixed reality comes with its own challenges. And sometimes you can end up spending as much time optimizing as much as coming up with new ideas. And combine that with high user expectations, and you definitely struggle with your creative aspirations. So this year at Meta, we have been focused on optimizing two crucial aspects of our technologies. First one is visual clarity, and the second one is compute optimization. With the improved visual clarity, we believe all MR experiences will be improved. And with the optimized compute, you will have more room to build some of the more demanding and complex projects, bringing your most ambitious ideas to life. So with that, let's jump into the specific improvements we have done this year. So firstly, we have improved the resolution, color fidelity, and dynamic range of pass-through. Pass-through is now higher fidelity than before. Pass-through is also better at adjusting to color, contrast, dynamic range, and exposure to match the real world. Like simply put, the real world look more accurate on the device. So for example, now if you want to read text or see images on your phone, you will be able to do so without having to take off your headset. Additionally, we have improved the performance of pass-through for low light scenarios. So pass-through is now less grainier. And this means that late night gaming marathons, productivity sessions, or entertainment experiences will look way more better now. Furthermore, we have improved the color tuning of pass-through for warmer environments. What does this mean? This basically solves for the color rendering gap that we had between VR objects and the real world objects. And this provides a more balanced and accurate color definition to pass-through. Now, secondly, we have improved the interactions with the real-world objects in pass-through. We have reduced distortions, and we have also significantly reduced the warping effect that used to happen around the moving objects. Now, this makes the real-world interactions way more smoother, engaging, and lifelike. So for example, now if you want to pick up a coffee mug from your physical desk, the whole interaction will feel effortless. Thirdly, we have worked on our hand interactions in pass-through. We have significantly reduced the misalignment between pass-through hands and virtual hands, and also reduced the hand distortions. Now, this increases the feeling of connection between your physical hands and virtual hands, and also make the hand interactions quality way better in pass-through. So, for example, imagine writing with a virtual pen. Now, the movement of your physical hands will match way more accurately with the virtual hands, giving you the confidence to work more precisely in pass-through and unlocking new use cases, as we can see. Now, the feeling of connection is important, but so is having uninterrupted mixed reality sessions. So this year, we released contextual pass-through. Contextual pass-through offers seamless transition from MR Home to your apps. It provides you two key pieces of information. One, user's context. Where is the user coming from? Are they transitioning from MR Home or VR Home? And what is the user's preference? Do they prefer a VR mode or MR mode? And using these two key pieces of information, you can design your loading screen transitions more optimally. Look at what Cubism has done. They have completely removed the jarring black screen transitions that used to happen in the past. Moving on, let's talk about dynamic occlusions. Now, dynamic occlusions created with Depth API provides you that next piece of believability to your MR experiences. And this year, we have made significant strides in optimizing Depth API. Now, dynamic occlusions have higher visual quality, lower compute utilization, and lower latency. So what does this mean for you? This means that all MR experiences will look way more captivating when using dynamic occlusions with Depth API. This also means that now you can make your MR scenes more richer, as you will be able to add more virtual objects to it given the less compute utilization of Depth API. So all in all, to summarize, we really believe that with these improvements, we have unlocked a door of possibilities for you. And we are truly excited to see the kind of immersive, engaging, and realistic experiences you will be building using these technologies. And with that, I'd like to bring back Kirk, who is going to talk about the tools that we have built to support these capabilities.
Thank you, Avinav. Boy, what a lot of improvements. You guys remember the grainy pass-through with Quest 2? And now this. So in case you haven't heard, there's this new thing, Quest 3S, that you can get for $299. So go out and get one. Anyway, okay, let's go ahead and get into the next area. Building MR apps. So let's step back for a second and talk about what does it really take to build an MR app. The Scene API provides you some basic information. It'll provide you the location, it'll provide you a semantic label, but that's really still a pretty low-level interface. What a developer needs to do is to be able to place the object that they're trying to place in the best place possible in the room that they're placing it into. But the issue with that, as we said earlier, is the rooms are changing, right? You have one room in one developer, one user, and a different room in another. So how do you define best, and how do you get that placed in the right place in any particular room? The MRUK provides spatial queries that allow you to do this. So you can ask questions like, okay, which object is closer to the user? Or which object has enough room to actually place something on it? When we were building our showcase app called First Encounters, we wanted to place a spaceship. And a spaceship can only go in a certain space, right? So where do you put it? You put it on the ground, you put it on a table. So knowing all of that is really important. And using the MRUK, you can do this. Another few examples. Let's say you have paintings. You wouldn't want to hang paintings on a wall, right? You're probably not going to hang paintings on your ceiling. So you want to filter for vertical surfaces or horizontal surfaces. So once again, using the spatial queries from MRUK, you can get the right placement for the object, and it can adapt dynamically to whichever room condition that you're dealing with. Those helpers that are provided by MRUK allow you to create this dynamic gameplay that is also adaptable in any particular room. But in addition to just the spatial queries, MRUK provides a few extra things. We have things like dynamic object spawning, and we'll go through some examples of that in just a second. Texture remapping, scene debugging, object resizing, and a lot more. Further, we're introducing several new features that we're going to go into in this presentation. Okay, new feature. Let's start with something really simple. Let's say that you're developing a cooking app. And in your cooking app, what you have is a recipe, but you want to just kind of stick your recipe up on a cabinet to the side so that you can look at your kitchen and do everything that you want to do. Now, you don't need a full room scan to be able to accomplish that. You don't need to know there's a refrigerator over there and a stove here and whatever, right? All you need is the Depth API and ArrayCast. We're introducing in an upcoming release in just a few months something called instant placement. What instant placement allows you to do is use ArrayCast to place any object. Let's take a look at how that actually works. In this video, I'm going to take this UI object and I'm going to move it over towards the wall. You'll see at this point it snaps to the wall. Now I want to resize it, so maybe I want it to be a widescreen TV. And now I'm going to try and place it again. But as I move it to the right, it's going to stop. So it's finding the space that you've got. Now, if I really want to move it, I can go ahead and drag it over to the wall and place it over to the other wall. But using just the raycast, it'll find a space for where you want to put it and allow you to center it very quickly. Now, that removes a lot of the inertia in creating some of the more simple APIs. You don't have to have a full room. You just want to create a portal, put it up against a wall. Real easy to do with the raycast API. And we think this is going to allow people to just create new things very easily and very simply that adapt to any place you want to put them in a room. Let's move on to another one and take a look at another query that we have. As I mentioned, one of the biggest challenges is that we don't control that room, right? It's going to be varying. It's going to change from room to room. This particular query, which is called MRUK find spawn position, that's a mouthful, allows you to place some filters on the object and then define any number of objects you want to place in any particular space. So you say, okay, well, I want to place 30 objects and I'm going to place them on a table, or I want to place them on a ceiling or the wall. In this particular video, what we've done, as you can see here, is we've told it just place a bunch of random objects, blue objects on the ceiling, red objects on the wall, green objects on the floor, light green objects on miscellaneous things. Now, this could have just as easily been red, green, and blue elves. You could have had them attacking each other at the boundary of the walls and doing whatever they want. But what this does is it gives you the capability, and the real power of this particular API is it gives you the ability to spawn random objects selected by a filter that can control either on orientation, proximity, amount of space, the type of object with a semantic label, a bunch of different parameters, and you can use it to adapt to play your particular game in a variety of different rooms without knowing what kind of room you're going into. Now that you've placed your objects, you want those objects interacting reasonably in that room. It goes back to the first part of the presentation where I mentioned you want the things that allow you to suspend disbelief. And with some of the performance improvements we heard about earlier, it's even easier to do that now. Now let me go ahead and play this video. What I'd like you to notice in this video is how natural Opie looks as he's jumping around. Oh, his name is Opie, by the way. What you can see is he's carrying a candle around on his head. I know that's kind of a weird thing to do, but Opie likes to do that. So as you see as he comes close to the objects, or particularly on this brown floor, you'll see the lighting interact from his candle as he's putting forward. Likewise, I would also like you to notice the shadows and what an effect they have. As he jumps up and comes back down, that shadow anchors him to the floor and really gives him that feeling of reality. Otherwise, he would tend to float in space. So with our effect mesh, you're able to implement all of this really quite easily. Okay, so you've got your character, you've got him placed, you know what he's doing, but now there's another issue. Probably the biggest immersion breaker in MR is when you have a virtual object that goes behind a physical object and you can still see it. You know, that just, your mind goes, whoa, wait a sec, something is definitely wrong here. So with the Depth API, it's easy to implement dynamic occlusion. The effect mesh supports occlusion shaders. So basically what you do, and let me go ahead and press this. So basically what you do is you apply these shaders. In this particular case, we've had a shader that just kind of shows his outline or darkens him up, but he could be anything, even the standard Unity occlusion shader, to have him disappear entirely. And that allows you to really take advantage of the Depth API in a very easy way. This is essentially just a one-click onto the effect mesh. Now, in addition to providing occlusions, which is super important here, we also provide you the raw information as part of the API. So with this, you get a per-eye depth buffer where you can pick it up and use it for other purposes. Let's say you could apply this to a material so you could have a fog that changed density based upon depth or any type of other event. Well, that's how we try and design APIs. We have a very simple use case that we try and go ahead and apply automatically, but then we'll give you the in-depth information so that if you want to go to the next level and use the same information for some other effect or for some other purpose, you still have access to it. let me talk a little bit more about appearance. In a lot of cases, what you would like to do is you'd like to paint the walls with a texture. Let's say you're a spaceship, and what you really want is all these walls to be really shiny and maybe have portals looking outside or whatever. So that's a very common effect that you would have in a game. You want to stylize it and apply a texture. But the issue with that is that sometimes you'll get this kind of bending and warping and tearing that will totally destroy the effect that you want to create. The image that I'm showing here, the top image is without the effect mesh. The bottom image is with the effect mesh. If you'll notice the differences in these two images, in the top image, you will see that the blocks are all different sizes and they're kind of a little bit oblong at times and all of that. If you look at the bottom image, are very close to the same size textures and they're uniformly distributed. What this allows you to do is to wrap these textures around different objects with no seaming, no distortion, no warping. And all this is provided as part of the effect mesh that we provide as part of MRUK, resulting in, of course, a much higher fidelity image. Okay, so where are we at here? We've got our object, we've got him looking pretty good, we've got the walls and everything looking okay, but maybe we want to spice it up a little bit. At this point, we have another helper function called the scene detector that will allow you to selectively sprinkle whatever object you want on whatever surface you want to just kind of spice up the room. So in this particular case, if you look at the left-hand half to the bottom, you'll see that the controller here has been set up to spawn 4 different things. If you look, it says floor 1, floor 2, walls, and desk. Now, in each of these, it's going to just go ahead and paint a different object that's controlled by the filters that we set up for it. And let me just show you how it looks. So in this first object, as we select it, we're going to spawn little pine trees. And so you'll see those as soon as I select it. There we go. You see them spawned on the floor. So now, again, this is kind of an example. You could do any object you wanted. I select the second one, or actually third one, and it spawns these little plant things all across the walls. And finally, I select stones, and you can see that it threw stones, both that went by pretty fast, but you see that there were stones both on the chair as well as on the table. So what this allows you to do is to dynamically react to any particular room and decorate it in different walls in a way that fits into your gameplay. Maybe you want tables always to have some particular object on them, a flower vase or whatever. It would allow you to do that. Maybe you want a bed to always have something else on it. Just can't go with my imagination on that one, but I'm sure you can. Okay, so we've got the character created, we've got them kind of interacting correctly in the virtual world, we've got the virtual world looking great, we've got it sprinkled around. But now we want to add a little bit of fun. I mentioned earlier we have a showcase app that's called First Encounters. If you haven't played it, go play it. It's really a lot of fun. In this, there was one particular effect that was just reused again and again, and it's called a destructible mesh. So basically what this is using the effect mesh, we then can paint a texture over it, and then you can use a ray cast to destroy objects, to uncover things. So you can think of a large variety of different gameplay mechanisms you could use this for. Let's say that I want to destroy this wall, this virtual wall over here, and this horde of aliens is going to come streaming in from it if I do. Or let's say I have an object that you have to find somewhere, but you have to go through and destroy things. So using this effect mesh, you can create that, and it comes straight out of the box. Just a few clicks, you're able to do it. In this video, the red here shows the effect mesh. I apply a texture to it, just a random texture, and then I'm using raycast to destroy parts of the texture to uncover, in this case, the painting, and in this case, my colleague Brian, who was preparing for Connect. So you can see you can use it to either open portals or uncover things in the physical world, or that could have been a virtual object behind either of those physical objects as well. So we hope you guys will use that and have a lot of fun with it, because it is just a really cool way to create some special effects. Okay, small to large scale. So I guess about a couple of months ago, we introduced our travel mode in Quest, which allows you to be in a very small space. So we started out with room scale stuff, which everyone's super familiar with. Now we have the really small scale stuff. Well, we also have large scale stuff, and that's what we're going to talk about now. Now, with MRUK, what we've done is we've created a nav mesh that allows you to seamlessly move between different rooms. So you can have one room adjacent to another room. In this case, the particular artist here was in her studio, and she wanted to move out into this open space, so you can take her from one space to the other. So for both simulation and navigation, you can join rooms together, have a particular nav mesh that connects those rooms, and so your characters can walk between those rooms seamlessly and really, do whatever they want. In addition to that, if you have two adjacent rooms, we can merge those rooms. So rather than asking you to create special things and align doors and do all of this, we'll take care of that for you. A single function call, and you can take two adjacent rooms and make sure they're merged together so that you can navigate between those rooms. Now, in addition to that, we have a lot of simulation capabilities so that we have those rooms and prefabs for those rooms so that you can test that and really make sure that works, not only in your home, but also in whatever other places that you want to test it for. So today we've shown you a lot of capabilities, improvements in perception, quality over the past year or so, as well as a bunch of tools with MRUK. We hope that this really helps you both understand and improve the perception side of things, as well as understand the interactivity capabilities provided by MRUK. We also have a slide here where you can pick up and get a lot more information, so hopefully you guys take a picture of that and can download. Thank you so much for your time and your attention. Thank you, Avana.